All right, let's dive right into this explainer on the unsung heroes of computer networking, IP addressing protocols. Whether you're architecting a multi-VLAN enterprise network, configuring a home lab, or honestly just trying to figure out why your smart TV keeps dropping off the Wi-Fi, the way your devices claim their identities dictates the stability of your entire network.
You've probably opened your smartphone settings and toggled between obtain an IP address automatically and manual 100 times. But what is actually happening at the packet level when you make that choice? Today, we're demystifying the architecture behind static and dynamic IPs and how they operate behind the scenes to keep all your data flowing seamlessly.
Here's our roadmap for today. First, we'll look at the IP address dilemma. Second, static IPs and the manual way. Third, dynamic IPs and DHCP magic. And finally, choosing the right setup for your own network.
Okay, part 1, the IP address dilemma, because every single device absolutely needs an identity.
Which brings us to part 2, static IPs, the manual way, the original networking method.
Let's establish the core rule of networking right now. Every single device has to have an IP address to exchange data. Originally, we fulfilled this requirement with the permanent, unchanging, static IP address. But to actually set one up, a human administrator has to manually open the device settings and painstakingly enter 4 distinct numeric codes. And it's not just random typing, there's real architecture here. You've got the IP address, which is your unique identifier, the subnet mask, which defines the specific local neighborhood your device lives in, the default gateway, which is literally the front door out to the wider internet, and the DNS server addresses, which translate human-readable web names into machine-readable IPs. All 4 are completely permanent, locked to that network interface card until someone manually intervenes.
Now, this manual entry is perfectly fine for your personal desktop at home. But imagine the sheer nightmare for an IT administrator back in the 1990s. Picture them armed with a clipboard, tasked with perfectly typing 4 unique numerical strings into 250 different workstations across a sprawling office. Walking around to every single machine to input these configurations was a massive drain on resources. It was basically a recipe for carpal tunnel, endless typos, and an IT admin's worst nightmare.
And all that manual data entry inevitably leads to human error, specifically a massive technical failure known as the IP address conflict. If you accidentally assign the exact same static IP address to 2 different devices on the same network, it creates absolute chaos at the protocol level. When both devices claim the same IP, the network switch's ARP table, that's the Address Resolution Protocol table, gets completely poisoned. The switch gets so confused about which physical MAC address actually corresponds to that IP, causing data packets to bounce aimlessly or just drop completely. The result? Both devices get knocked completely offline.
So, how do we fix that? Let's move to part 3, dynamic IPs and DHCP magic, our automated hero.
To eliminate all that manual labor and prevent those disastrous ARAP conflicts, network engineers developed a much smarter solution. Born back in 1993 as an evolution of an older, much more rigid protocol called BOUTP, DHCP entered the scene. DHCP stands for Dynamic Host Configuration Protocol. Today, a DHCP server runs silently in the background of your internet router or on a dedicated enterprise server, acting as a massive pool of available addresses that are ready to be handed out dynamically at a moment's notice.
This automated assignment happens through an incredible sub-second microstory known in networking as the DHCP process. Discover, offer, request, acknowledge. It goes like this. First, your laptop wakes up and broadcasts a discover packet to the entire network to see if a DHCP server is out there. Second, the router offers an IP from its internal pool, known as the DHCP scope. Third, your laptop requests to officially use that specific IP. And finally, the router acknowledges, silently delivering the IP, subnet mask, gateway, and DNS straight to the device. And all of this happens in literally milliseconds.
But here is the brilliant catch. Your device doesn't actually own that IP address forever. It's strictly a temporary arrangement. The DHCP server issues the IP address as a lease. Think of it as a predefined countdown timer, often set to 24 hours, sometimes just a few days, governing exactly how long that device is allowed to use that specific identity before it has to check back in.
This lease system is genius because it prevents a crippling phenomenon known as DHCP exhaustion, which is when a network runs entirely out of available addresses. When you're actively connected, your device doesn't wait for the lease to run out. Usually right around the 50% mark of the lease timer, it automatically sends a message asking to renew and extend its time. But when you leave for the day and disconnect your laptop, those renewal requests stop. The second that countdown timer hits 0, the router reclaims the IP, aggressively tossing it right back into the pool for the next person to use.
This takes us to part 4, choosing the right setup. Let's break down exactly when you should use static versus dynamic.
For almost all of your everyday client devices, dynamic is the effortless, obvious choice. It lets constantly moving devices like smartphones and laptops join and leave completely seamlessly. But infrastructure hardware, like an office printer, a web server, or a NAS drive, absolutely must use a static IP. Think about it. If your primary DNS server or network printer changed its IP dynamically overnight, by the next morning, every workstation in the building would be throwing error codes, desperately trying to route traffic to a ghost address that just doesn't exist anymore. Infrastructure needs an anchor.
So what if you need that bulletproof consistency of a static setup, but you absolutely loathe the manual nightmare of typing network configurations on a clunky printer interface? Is there some kind of middle ground?
Enter the ultimate networking cheat code, the DHCP reservation. Inside your router's brain, you can simply link a desired IP address to your device's MAC address. That's the permanent physical identifier burned right into its network silicon chip at the factory. When the router sees that specific piece of hardware broadcast a Discover packet, it completely bypasses the random pool and hands it the exact same reserved IP address every single time.
To bring it all together for you, dynamic IPs are your automated, rotating assignments designed perfectly for everyday clients. Static IPs are your manual, permanent anchors essential for servers. And DHCP reservations give you the absolute best of both worlds, providing that static reliability with completely automated delivery.
I really encourage you to log into your own router and check out the DHCP scope tonight. See how many ghost leases are currently clogging up your network. Maybe you have a rogue device that desperately needs a fixed reservation to stop dropping off. And as you're doing that, consider this. With the massive explosion of Internet of Things devices putting a smart network chip in literally everything from our refrigerators to our light bulbs, how much longer can this IPv4 system actually survive before we run out of addresses entirely? Something to think about. Stay curious and keep learning.